we're still stuck at home, but we do have some things that we still want to show you. So thanks for watching. If you notice, I'm washing my hands. By now you've heard it 1,000 times, wash your hands. You've been told to wash your hands for 20 seconds with soap as often as you can. But do you know why you should be using soap when you wash your hands? Well, we're going to tell you. We all need to do our part in stopping the spread of coronavirus, and one of those ways is to not become a carrier and spread it to others. Washing with soap is important for getting rid of coronavirus. How? Let's take a closer look at the coronavirus. You may have seen pictures like this, the coronavirus molecule. Basically, a coronavirus is a bunch of genetic material, or RNA, that wants to go in and hijack a cell. The infected cell reads the RNA and makes copies of the virus. But the RNA can't just get inside your cell unless it can get through your cell membrane. So to do that, the viral RNA is wrapped up in a protective package, a layer of lipids, which are fat molecules similar to oil. Stuck inside the fat are different kinds of proteins, including the ones that stick out. Think of your cell as a house with a locked door. The coronavirus RNA can't get inside without the right key, otherwise it can't unlock the door. The keys that the coronavirus uses are in the form of those proteins that are stuck on the fatty surface. By having this protein in its lipid layer, the virus RNA has access to your cell. The point of using soap to wash your hands is to destroy the package before it can get to your door. Before we tell you about how washing with soap helps protect you from COVID-19, there are a few things you need to know. This is a water molecule. You may have heard its other name, H2O. It's made up of 2 hydrogen atoms and an oxygen atom. So one side is positively charged and the other is negatively charged. If you have a droplet of water, there are millions of these little molecules floating around, and they're slightly bonded together because of these charges, which keep them together. Have you ever noticed that oil and water don't mix? Oil, or fat, is a lipid. Lipids generally don't have a charge, but they definitely don't like water. If you pour some oil into water, you might notice that it'll float up to the surface, and little bubbles of oil will clump together in an effort to get away from the water. Now this is a soap molecule. Soap works to break apart a coronavirus basically because of how it interacts with water. 1/2 of a soap molecule is hydrophilic, meaning it likes water, and the other half is hydrophobic, so it doesn't like water. The hydrophobic side doesn't mind lipids though. Water, which is also polar, attracts the hydrophilic side of the soap molecule. But that means the other side of the soap molecule is trying to get away from the water. And if there happens to be a lipid nearby, the soap would much rather be with the lipid, so several soap molecules will cluster around the lipid. Now remember, the coronavirus package consists of some genetic material wrapped up in fatty lipids. So if we can break apart the fat, the package won't be able to hold on to its proteins, and the whole coronavirus will break apart. So imagine you get some coronavirus on your hands. When you wash your hands, you add water, and then you add soap. In an effort to get away from the water molecules, the soap tails wedge themselves into the fatty coronavirus wrapping and break it apart. Each fat molecule becomes surrounded by soap molecules, forming a structure called a micelle. The rest of the coronavirus molecule, the proteins and genetic material, gets separated. Now the viral RNA doesn't have a key and can't infect your cells, so it becomes harmless, and you can just wash it away. Now let's take a closer look at what soap does when you wash your hands. Remember, coronavirus is basically a lipid capsule with proteins inside of it surrounding some viral RNA. The RNA is what you don't want getting into your cells because that's what replicates and spreads the disease. In our demonstration, we'll use olive oil to represent our lipid and we'll use black pepper, which is easy to see, to represent the viral RNA. If we can get the pepper out of the oil, it'll lose its ability to infect your cells, and it'll be really easy to wash away. If you go to the supermarket and touch something that has been infected, you'll get some coronavirus on your hands, the surface of the water. The viral RNA, protected by the oily lipid layer, is just waiting to get into your cells. But right now, your skin is protecting you from getting sick, so you need to get rid of or destroy that coronavirus. If you think of the surface of the water as your skin, you can see how much viral RNA is being protected by the oily lipid. Let's see what washing your hands does. In this case, we'll stir our water to represent washing. If you just wash your hands with water, but without adding any soap, you may be able to remove some of the coronavirus, but you won't be destroying the lipid package. Plenty of viral RNA can still be seen protected by that thick bubble of oil. Now let's try adding a bit of soap. We'll use regular dishwashing liquid, no antibacterial or anything, and we'll scrub for 20 seconds. One of the reasons why 20 seconds is important is because your hands are full of nooks and crannies. You want to be able to get into all the crevices. Plus, scrubbing your hands helps the hydrophobic ends of the soap molecule break apart the lipid layer and form those micelles. It needs time to dismantle the coronavirus package. Remember, without the oily protective coating, the RNA doesn't have the key that would allow it to get inside your cells. You already see the viral package is breaking apart. The oil is no longer able to stay together, and most of the viral RNA is now neutralized. When we look closely at the surface of the water, the oil is having difficulty clumping together, and the pepper is no longer protected by that bubble of oil. After several more seconds, even more viral RNA has come apart from its lipid protection. When you compare the two samples, the top one washed with soap and the bottom one without soap, it's easy to see how soap is better in breaking apart and destroying coronavirus. Thanks for watching! We hope you learned a bit about the importance of soap, and we hope that you'll keep washing your hands. See you next time!